we're given that the half-life of strontium-90 is 28 years. Now, what does that mean? That means that after 28 years, that strontium-90 will have decayed to half of its original amount. So we need to find an exponential decay model for that so we would be able to solve it later if necessary. So we're going to use the A equals A naught e to the kt. Now, the initial amount is the A sub 0, the A naught. Now, when we look at this, we're talking about half-life, correct? So if it's half-life, that means it would be half of whatever we started with. So that means that A will equal to the original amount divided by 2. Oh, well look, I can plug that into my formula over here and get A naught over 2 equals A naught E. Now, do I know anything about K or T? Well, I know the time. It told me it was 28 years. So that's going to be K times 28. So what I need to do now is I need to solve this and get the E term all by itself. So if I'm going to do that, I'm going to divide both sides by A naught. On the right side, the A naughts will cancel, and that will give me E to the 28K. Over here on the other side, the A naughts cancel as well, and I'm left with 1/2. Now, what is the opposite of E? Well, that's going to be your natural log, so I'm going to take the natural log of 1/2 equals the natural log of E to the 28K. And if I remember correctly, remember the ln and the e's cancel one another out, so I'm left with the natural log of 1/2 equals 28K. But I need to get K all by itself, so I'm going to go ahead and rewrite it over here so we can all see what I'm doing. So that equals 28K. We want to get K by itself, so we're going to divide by 28. And again, remember, anything over itself is 1. So now what I need to do is I need to actually find the natural log of 1/2, divide that by 28 to get my answer. And when it comes out, I get negative 0.0248. So that's going to be my K. So if I were to rewrite this model, I would get A equals A naught E to the negative 0.0248